Hi friends, I'm going to teach you a subject of electromagnetic theory. I'm Nageshwari, Assistant Professor, Department of EEE. In the subject electromagnetic theory, we start with the Unit 1 that is electrostatics 1. Let's start with the journey of electromagnetic theory. In my previous videos, I discussed detail about the syllabus of electromagnetic theory and we started electrostatics 1 that is Unit 1. In my previous videos, I discussed about the sources and effects of electromagnetic fields and also I started coordinate systems and there are three type of coordinate systems. So one coordinate systems I discussed already. Now in this video, we are going to discuss about the second type of coordinate system that is cylindrical coordinate system. As I discussed already, a coordinate system is a method for identifying the location of a point on the earth. The different types of coordinate systems mentioned earlier as Cartesian coordinate system, cylindrical coordinate system and spherical coordinate system. Now let me discuss about the cylindrical coordinate system. Now, here shows the structure of a cylindrical coordinate system. Now, what is cylindrical coordinate system? Just like in Cartesian system, we obtain a point by intersection of three mutually perpendicular plane surfaces. In this system, also a point is obtained by intersection of three surfaces mutually perpendicular to each other. But the difference between the Cartesian and cylindrical is nothing but all three surfaces are not the plane surface because this one is a cylindrical coordinate system. So therefore, like in Cartesian coordinate system, here all the three sides are not a plane surfaces, only one is cylindrical and other two are the plane surfaces. Whereas in Cartesian coordinate system, all the three surfaces are plane surfaces, whereas in cylindrical coordinate system, one surface is cylindrical surface and other two are the plane surface. In the cylindrical system, again we are taking x, y and z axis for reference. X, y and z axis for reference. Now imagine a hollow vertical cylinder of radius pi placed such that axis of the cylinder coincides with the z axis. So this radius rho, this axis of this cylinder coincides with the z axis. If you take any point on the cylindrical surface, it is at a same distance rho from the axis. Therefore, we define the cylindrical surface as rho is a constant surface. Why? Because rho is constant throughout the cylindrical shape. If we take a point anywhere from cylindrical surface to z-axis, the distance between that point to the z-axis is the same throughout the cylindrical surface. So therefore, rho is a constant surface. Now consider a plane vertical surface of which one edge coincides with the z-axis. We can rotate this plane about z-axis. So the angle of rotation phi is measured from xz axis. So this angle of rotation here, this is nothing but the angle of rotation we can consider as phi. The angle of rotation consider as angle of rotation consider as phi. So we can take any point on this plane, every time the angle of the point with xz plane is phi. So this phi is the angle with the xz pi, xz plane. Therefore, we define this plane as phi is a constant plane. Of course, this phi is also a constant one. Now, the third one. Thus, we have to here, therefore, we are having two new surfaces. One is rho, rho is a constant, and other one is phi, phi is a constant surface. The intersection of these two surfaces is a vertical line. Now, another point is a z point. So, that z point is also a constant plane. So, therefore, here in cylindrical coordinate systems, so we are having the three coordinates are rho, phi and z. Rho is a constant, phi is a constant and also z is a constant. So therefore the ranges of x varies from minus infinity to plus infinity and also y varies from sorry rho varies from here rho is nothing but the radius. The radius rho is varies from 0 to infinity and phi varies from 0 to 2 pi. Why? Because here the angle of rotation is about 360 degrees. So therefore, so we can say the phi varies from angle 0 to 2 pi and now in this slide we are going to see the different unit vectors of cylindrical coordinate system and as well as what are the different elements, differential elements of cylindrical coordinate system in detail. Now, let me see a projection of a cylindrical coordinate system. As I mentioned already, there are three coordinates in a cylindrical coordinate system. There are rho, phi, and z. So, we can say the unit vector of rho is arrow vector and unit vector for phi is nothing but a phi vector and the unit vector for z is az vector. So, therefore, a rho and a phi according if you see the left hand side left topmost side diagram is nothing but the unit vectors diagram. Now, the arrow and a phi is perpendicular to each other whereas az and arrow is also perpendicular to each other. Now what is rho? So again I repeat, rho is nothing but the radius of cylinder and phi is nothing but the angle made by rho with respect to x and z is the height of the cylinder. Now if you see the right side of the diagram, so this diagram represents the a main projection of this cylindrical coordinate system. So if you look at the diagram, so the diagram shows the points, so P, C, B, O. Now if you see this PC is like a curve like structure and if you take this BC, again this BC is like a plane surface. Again this OB is like a curve like structure and again if you see AC or the vertical line AC is nothing but the plane surface. So what we can say is there are three sides of cylindrical coordinate system. The one side is nothing but the rho side. That means rho, d rho side. That means radius side. So the radius side is nothing but d rho. So that is one side. And the other side we can say it is in the z axis. So therefore we can say the other side is dz side. Now what about the third side? The third side is nothing but the phi. So now how we can define the third side? So that means, so if you increasing the first coordinate by differential amount d rho results in differential length d rho, and also if phi is increased, that means the angle of rotation, that phi is increased by differential amount d phi, this will result in an arc along with the radius rho and angle subtended d phi. So therefore the length of the arc in the angle of rotation is given by rho into d phi. That is about your second side. So, therefore, let me conclude the three sides. In a cylindrical coordinate system, one side is along the rho direction, that means d rho, and the third one is nothing but along the z direction, therefore the side is dz. Now, if you take the second direction, that means phi along with the phi direction, so if you increase that phi, it will increase along with the radius rho, therefore the second side is nothing but rho into d phi. So these are the three sides of cylindrical coordinate systems. Now let us see the differential elements of cylindrical coordinate systems. In previous slide, I discussed about the what are the unit vectors and as well as what are the different coordinates and different sides of a cylindrical coordinate systems. Now in this particular slide, I am going to explain what are the different differential elements of cylindrical coordinate systems. Now, first we will see the differential length. So, as I told you already, there are three sides, that is d rho, rho d phi and dz. So, now just you can write along with the unit vectors. That's all. So, therefore, the differential length dl is equal to d rho into a rho vector plus rho into d phi into a phi vector plus dz into az vector. So, this is the differential length of the cylindrical coordinate system. Now comes the cylindrical coordinate systems differential surface. So, as I told you in my previous lecture, the differential surface is nothing but the combination of two sides. Surface is nothing but the area element. So, therefore, we can say the area is nothing but the multiplication of two sides. So, therefore, here we are having the three directions. So, therefore, we are having the three formulas of differential surface. So, the first we are going to see the formula along with the direction of arrow vector. So if you see the first diagram, so in the first diagram, if you see the bottom diagram, it is very much clear that arrow vector is perpendicular to rho d phi side and dz side. So if you take the bottom side of the second picture, if you take the bottom side of the second picture, the first bottom side is nothing but the main projection diagram of a differential surface. Now, if you see along first one is along the arrow vector. So, this arrow vector is perpendicular to the two sides rho into d phi and dz. So, therefore, the differential surface formula is given by rho into d phi and as well as dz into arrow vector. Now if you take the second one, second diagram in the bottom side is nothing but along the a phi direction. So in along the a phi direction, so that a phi direction is perpendicular to two sides, that is dz and d rho. So therefore the differential surface formula is given by d rho dz into a phi vector. Now comes the third formula is along the AZ direction. So this AZ is perpendicular to the both d rho and rho d phi side. So therefore, we can say the formula ds is equal to d rho into rho d phi into az vector. Now, next one is we are going to see about the differential volume. So I said I already mentioned the differential volume is nothing but the combination of all the three sides. So therefore dV is equal to d rho into rho d phi into dz. So if you align this properly, so finally we will get the formula dV is equal to rho d phi and dz. So that's all about this differential elements of cylindrical coordinate systems. Now, so let me conclude about the cylindrical coordinate systems. That means the first we discussed about the unit vectors of cylindrical coordinate systems, that is arrow, a phi and az. And the second point we discussed about the ranges of cylindrical coordinate systems, that is coordinates of cylindrical coordinate system. The range for rho is nothing but 0 to infinity. The range for phi is nothing but 0 to 2 pi, and the range for z is nothing but minus infinity to plus infinity. Next, we discussed about the different sides of the coordinate system. That means here in cylindrical coordinate system there are three sides. One is nothing but the d rho, second one is nothing but the rho d phi, third one is nothing but the dz. Now next we discussed about the differential elements and finally concluded that so these are the different points in a cylindrical coordinate system. Thank you for watching this video.